So let's do another relative motion problem. Let's imagine you have an airport, and at the airport, there's a very long concourse and a little moving sidewalk. So we've got this moving sidewalk, and the sidewalk is moving at some velocity s of 2.5 feet per second. And you need to go 150 feet. And we have three passengers. We'll call this passenger A, passenger B, and they're both on the sidewalk up here, okay, and then passenger C, which is walking beside the sidewalk, okay. So passenger A is boring and just standing there. Passenger B is walking, and then passenger C is walking. So passenger B is walking with a velocity, leisure velocity of just taking their time walking down here at 2 feet per second on the moving sidewalk. Okay. Passenger C is walking at a velocity of 3.25 feet per second beside the sidewalk, and then passenger A is just standing there. And so the question is, how far does everybody go and how many steps do they take? Okay, so we think about it, and this is pretty simple. Let's do passenger C first. Passenger C is walking at a certain speed, going a certain distance. We're going to assume that each step that everybody takes is 2.75 feet just to make the math easy. So passenger C is walking a distance of 150 feet, and they're moving with a velocity of 3.25 feet per second. So the time is real simple. 150 feet divided by 3.25 feet per second. And so that comes out to be 46.2 seconds. Now, how many steps? The number of steps is going to be 150 feet divided by 2.75 feet per step. And so that comes out to be 54.5 steps. We can't have half a step. Half a step is just a small step. So this is 55 steps. Okay, so that's passenger C. So let's do passenger A now. Passenger A is the boring one. They're just standing, not moving on the sidewalk, and the sidewalk is moving at 2.5 feet per second. So that's carrying them down the concourse. So the time is going to be 150 feet divided by the 2.5 feet per second. And so that comes out to be 60 seconds. So that's 1 minute to get down there. How many steps? Well, you could say the number of steps, n equals 0. And I would accept that. You could also say n equals 2. You step onto the sidewalk and step off. And I would accept that too. So if this were a problem on a test and I asked how many steps, then you could say didn't take any steps because he wasn't walking, or you could say took 2 steps, 1 to step on, 1 to step off. I'd take either one of those. Just explain. Okay. Now passenger B is the tougher one. Okay, so passenger B is on the sidewalk. The sidewalk is moving at 2.5 feet per second. And passenger B is walking on the sidewalk at 2 feet per second. So the total velocity here is going to be the combination of the two, because you're walking at 2 feet per second relative to the sidewalk, and the sidewalk is moving relative to the terminal. So that means the total velocity is 4.5 feet per second. So the time will be 150 feet divided by 4 feet per second. And so that comes out to be 33.3 seconds. Now, how many steps? Problem is the person's walking on the sidewalk, but the sidewalk is moving, so they're moving part way down the sidewalk, and the sidewalk's carrying them the rest of the way. So to find out how many steps the person takes, we find out how far down the sidewalk did the person walk. Well, the person walked for 33.3 seconds, moving at 2 feet per second. So the relative distance on the sidewalk is going to be 2 feet per second times 33.3 seconds. So that's 66.6 feet. So that's the relative distance. So the number of steps will be 66.6 feet divided by 2.75 feet per step. And that comes out to be 24.2 steps. Well, 0.2 steps is just a very small step, so that rounds to 25 steps. You can't have a fraction of a step. That's still a step, just a small step. And so this is a total of 25 steps. Okay, so again, this is an example of relative motion.